Welcome, everyone. Thank you for joining another NetHope webinar series. Today we'll be talking about practical implementations of AI and ML in conservation contexts. And today we welcome representatives from Carnegie Mellon and the Nature Conservancy. Before we get started, I'm just going to go over a few housekeeping guidelines for today's session. We'd like to keep this interactive. Please post your questions in the Zoom chat window, and we will have a Q&A session toward the end of the hour. Please look for a follow-up email, which will include a recording and any collateral links on the NetHope Solutions Center. And we hope that you will take a few minutes at the end of the session to respond to our webinar satisfaction poll. It'll pop up in a new browser window after you close out the Zoom meeting. And with that, I will hand things off to my colleague, Layla Toplik.
Thank you, Madeline. I'm Layla Toplik. I lead the emerging technologies work at NetHope, including the work that we do around AI. And before we get to the topic for this webinar, I want to give you an overview of what we have planned for the next couple of months as part of the capacity building specific to AI. So Madeline, if we switch to my first slide, fantastic. So last month, we hosted an AI primer webinar where we covered basics of AI and machine learning, including AI capabilities and how they're being used in our sector today. And we will, if you didn't get a chance to join the webinar, we'll share the link to the recording and slides in the chat window. So do take a look at that, especially if you're coming to NetHope Summit. So today we'll transition to talking about practical implementations of AI in our sector. And the goal here is for all of us to learn from the current practical implementations of AI, and then also scale and reuse what works and partner with the organizations that are already doing this work. And then at the summit, we have several sessions planned as part of the overall emerging technologies track. So if you haven't registered for the summit yet, I believe the registration deadline is October 7th, so hopefully this will give you some context and reasons why to come to NetHope Summit. On October 21st, as part of the AI working group, which is open to all NetHope members, partners there by invitation only, we'll have two segments on October 21st. First, a working session focused on ethical AI, where we'll explore practical example that highlights some of the risks, issues, and also path to achieving ethical AI. And we'll discuss a number of questions, including what is an ethical AI solution? How do you know that you have it? What are some of the criteria that could be used to achieve ethical AI? And then following that session, we'll have time dedicated to learning about AI and ML tools and services that are ready to be used in nonprofit work. So expect to see a number of demos of off-the-shelf tools and services from partners like Microsoft, Google, Salesforce, and others. So that's on October 21st. On October 23rd, we'll have two sessions. In the first session, we'll continue learning from the practical implementations. This time, the Carter Center and Plan International will share their practical implementations and what they're learning. And then the second segment is a hands-on segment. So where all of you are invited to bring some of the problems that you're looking to solve, both from field programs and also internal operations, and work with technical subject matter experts from organizations like Microsoft, Google, Salesforce, USAID, to evaluate if any of the AI capabilities could contribute to the solving of those problems. So that's a hands-on segment, and the first session is a prerequisite to participate in the hands-on segment. So for those of you who won't be joining us at the summit, we'll package up some of the summit content and key takeaways and share them via future webinars and also on the NetHope Solutions Center. So going to the next slide, and to frame what you're about to see, I wanted to give you just a brief introduction to the framework we've developed, and you'll have the opportunity to read through these slides after we share them with you. via the email that you'll receive following this webinar. So this framework was designed to guide nonprofits as well as supporters through the evaluation process to determine suitability of AI for international development programs and also to plan for sustainability. As you can see, it was driven by the need from the sector, informed by our AI working group around needing more practical tools, not just principles around using AI in our space. And it's been developed through an iterative and consultative process that involved NetHope members, partners, supporters like USAID, and it's being designed to be used by different stakeholders, so including practitioners, technologists, and donors. This timeline just shows you this iterative process and where we're at today, and also what's coming up. So we'll be using that framework in the hands-on segment at NetHope Summit, and we'll package it up once we run this additional test and gather more input. Going to the next slide. So the reason why I'm sharing this with you is that out of the set of about 32 questions that we have for you to use to ask at each stage, from defining the opportunity for AI to evaluating data and bias to resourcing the solution, implementing the solution, maintaining and extending the solution, our presenters today will use 8 questions to take you through the practical implementations that they've been working on. So with that, it's my pleasure to introduce 2 fantastic presenters. Fei Fang, assistant professor at the Carnegie Mellon University, had the opportunity to share some of this work in NetHope's AI for Good workshop at the Global Summit, AI for Good Global Summit at the UN in Geneva. And Fei will talk about how we can use AI to protect wildlife. Fei also represents a group or an ecosystem of partners involved in this work, including some of the NetHope members. And then Francesca Tonini, a geospatial scientist at a NetHope member, the Nature Conservancy, will talk about how we can use AI to map conservation and tourism value of the marine ecosystem. So I'm really excited to welcome both Fei and Francesca, and we'll start with Fei's presentation. Over to you, Fei.
Hello?
We can hear you.
Okay, great. Thank you, Leila, for the introduction. Yeah, thank you all for attending the webinar. So today I just want to give you an introduction of PAWS, Protection Assistant for Wildlife Security. This is an application tool that we built for anti-poaching. So basically, we know that nowadays we have the conservation agencies send well-trained rangers to the protected areas and trying to find snares placed by the poachers or catch the poachers on site so as to protect wildlife from poaching. And then what we are trying to do is to help improve this practice using artificial intelligence. So next slide, please. So what the problem we're trying to solve? Well, yes. So currently, the wildlife conservation agencies and national parks lack quality tools to design this effective patrol routes to prevent poaching of wildlife in large-sized national parks, because there's the size of the national parks is usually huge, but the number of patrol resources is so limited. And as a result, as you may see today, the key species, the population of key species such as tigers, elephant, rhinos has dropped significantly. And in the recent years, one of the major drives is poaching. So what we're trying to do is to just save the wildlife from poaching. Next, please. So currently, it's basically the site managers are designing the patrol routes using the paper maps and using the past patrol routes and findings visualized by smart software. So currently, SMART has been used by more than 800 national parks. So it is a tool for people to record where they find things and what they find. And then also for the site managers to see a summary of the past findings so that it can help them to make better decisions. However, it is still like this decision making is still done manually, and what they have right now is just a simple visualization of what has been they have patrolled before and what they have found before. And as a human designer or human decision maker, he needs to account for many different variables, including the animal density, the distance to the village or the roads, because the poachers usually come from the roads, and also whether it is on an existing trail or not, because if you're starting a new trail, then it means that there's an overhead to just making your way through the path. And what are the limitations of these current practice? Emma Stokes, a conservation scientist from Wildlife Conservation Center, once mentioned that in most parks, ranger patrols are poorly planned, reactive rather than proactive, and habitual in their deployment. And in fact, this also shows that this whole way of human-designed patrol routes suffer from this very time-consuming process, and the human designers, human decision makers may have their own bias, and their bias has been injected into their planned patrols. For example, the site manager may believe that this part of the park has a lot of poaching going on, and as a result, he asks the rangers to go to that area way more often than many other areas. In addition, once the patrol routes gets designed, there's no frequent update, meaning the patrol routes are used for months or even years. Next slide. So why do we need AI? Why is AI potentially better than the current solution? The first benefit of using AI is that it hopefully can reduce the cognitive burden a lot from of the human decision makers, because now the decision makers can make more informed decision and design based on more information and analysis. And as a result, the human decision makers may spend less time on it, and which means they can manage even more parks at the same time with just the same amount of time. And also for the less experienced managers, now with the help of the tool, they can also handle the task with in a better way. And on the other hand, another benefit that AI can bring is that the rangers can make the most out of the patrols, because now these patrols can exploit the existing data to find the patterns in the poaching activities, which is done basically by machine learning. And also with the help of computational game theory, then now the patrols can account for the poachers' adaptation to the patrols and design targeted and proactive patrol routes. So on the right, we just show this diagram where we use artificial intelligence, which combines machine learning and game theory for and provide solutions for the anti-poaching task. Next slide. So the solution we provide is called PAWS, Protection Assistant for Wildlife Security. What it essentially does is that it takes into account past patrolling and poaching information, as well as information about the protected area. And based on these information, it tries to learn the behavior model of the poachers and then do game theoretical reasoning upon this poacher's behavior model. And it interacts with this module called route planning, which takes into account the terrain information of the area and then generates suggested patrols. And as we send the suggested patrols to the hand of the rangers or the site managers, the patrollers can execute the patrol routes and then collect the more poaching data, and which can feed back into the system and further improve the future patrol routes designed. So overall, it is an AI system that can help the park rangers design effective patrol routes to prevent poaching of wildlife in large-sized national parks. So next. So to use PAWS, what kind of data do we need? We first need patrol data that describes past patrol routes and the findings of poaching signs along these past patrols. And we also need geospatial data, which includes the location of the villages, roads, and rivers, and the slope, elevation, and land cover, and animal distribution, as well as anything else that is relevant, for example, MPPs, and sometimes even the boundaries of the farmlands and the boundaries of different types of forests. And how can we get this data? For conservation sites that are already using the smart software to record the patrol and findings, the patrol data can directly be extracted from there. And the geospatial data can either be provided by the GIS experts, or there are some publicly available data sources, but those ones are usually less fine-grained. So if the GIS experts for a specific conservation site can provide high-resolution, fine-grained DEM map, for example, that would be helpful. But DEM is probably not the best example, because DEM can also, high-resolution DEMs can also be found from public sources. But for other sources, like the exact location of the roads, not just the big roads, like province level of roads, but also the village level of roads, detailed information about them would be helpful. So next slide. So how can we support the development and implementation and maintenance of the solution? Luckily, so far, we get the chance to collaborate with many conservation agencies around the world, including some of the NetHope members like WWF and WCS. We also collaborated with some more other conservation agencies like Uganda Wildlife Authority, Panthera, and RIMBA. And all these collaborators provides a lot of support for our development and deployment and testing of the PAWS application. So technical part, this GIS experts provided data and import the solution of PAWS. And from our side, we have the students who analyze the data and process the data. We also need computing resources to train our machine learning models and to compute the patrol routes. But as I said, our collaborators provides enormous help and input to this to PAWS, and they convey the domain knowledge and provide feedback, including what kind of poachers they are facing, what factors do they consider in their manual design of the patrol routes, and which parts of the prediction that we provided or the suggested routes we provided are not reasonable, and why is that? In fact, because of this feedback and iterative development, we actually went on patrols together with our conservation agency collaborators like Panthera and RIMBA to go on patrols in the protected area, from which we can get a better understanding of what went wrong in our initial solution and then build upon it and improve the solution. So next slide, please. So yes, just as humans can introduce bias, AI may also introduce bias. And in this case, specifically because we predict the poaching threat based on historical patrol. And if there are areas that have been patrolled much more frequently than others, then AI's prediction will be more reliable for those areas. And then for other areas, it will be less reliable. But to compensate this issue, what we have tried different things. We have tried to elicit additional information from the human experts to compensate this historical patrol bias, because the human site managers may tell us that we didn't patrol that area very often because we know already from our domain knowledge that that area don't have a lot of poaching activity going on. Of course, their knowledge might also be biased, but kind of combining all these different pieces of information can help us mitigate some of the bias issues. And also, when we present the results to our end users, we not only present the predicted poaching threat level at different area, we also present how uncertain our prediction is. So this can also provide, this additional piece of information can also help reduce the bias issue in the solution. And another thing is that when we design patrols, we may want to balance exploration and exploitation. Because currently, most of the time, we try to exploit what we have found from the data. However, you may imagine that for the area that we don't have much data for, we may try to deliberately send rangers to those areas to collect more data. And this is something that we are working on as well. And I think there's other aspects, and I would like to see new generations of our PAWS solutions that can be better and better and try to do a better job in addressing these biases and make the balance. Next slide, please. Yeah, so to maintain our solution, first of all, we have this long-term collaboration with WWF and other conservation sites, and we're going to test on more sites and explore and address more problems. In addition, we have this open source code repository about PAWS, and we would like to invite different research groups to contribute to it. And more importantly, currently, we're collaborating with industry for further maintenance. We are collaborating with Microsoft, who's developing an API of PAWS, and that API would be integrated into the smart software, and now in the future, it will become a new feature in the next generation of the smart software. Actually, I'm just back from a trip from Boston where we have this smart PAWS integration meeting where we just discussed the exact timeline to do it, and we're expecting a version of the feature integrated into Smart fairly soon, within 1 year. So please stay tuned. So next slide. Yeah, so we have run several field tests in Uganda, Malaysia, and China, from which we do find all kinds of poaching signs and human activity signs in the areas that are not frequently patrolled before, and sometimes are not even known as poaching hotspots to the site managers. Next slide. And we also have the open source software. This is just a video showing that people can choose different machine learning models. This is a toy example area, but as I said, in the future, this would possibly be a feature in Smart, so hopefully it can be easily used by conservation sites all around the world. So next slide. So in the end, I would like to mention that here are some call for actions. Please help us spread the word about PAWS, share it with your network, and if you're interested in collaboration related to wildlife conservation using AI, contact me. My expertise is in computational game theory and machine learning and deep learning. And in addition, recently we're looking for high resolution satellite imagery data for detecting illegal mining and logging sites, which indeed these would contribute to the problem of poaching. So if you're interested in contributing data or using the resulting detection tool, contact us. So thank you all.
Thank you very much, Faye, for a really insightful and informative presentation. As noted, if you have any questions for Faye, please post those questions in the chat window. We'll get to the questions during the Q&A segment. And now we'll switch over to Francesca, who will talk about a practical implementation that the Nature Conservancy is leading. Over to you, Francesca.
Hello, everyone, and thanks a lot for giving me this opportunity to represent the Nature Conservancy and present to you all a very important work that was started about 4 or 5 years ago. The work is led by Dr. Mark Spaulding and Kate Longleywood, who are 2 members of TNC in the Oceans program. Next slide, please. So it has been estimated that by 2050, our planet's population might swell toward 9 billion. And so as you can imagine, one of the consequences is that demand for food, water, and energy will strain our natural systems, and especially our ocean and coastal ecosystems. In general, if you're not too familiar with the concept of ecosystem services, there is plenty of published literature out there. But when we talk about ecosystem services, we mean the benefits that natural ecosystems provide to people. And there is further classification between different types of ecosystem services. So if you're interested, feel free to check out some of the online resources on this. So our ocean ecosystems are as varied as they are valuable. So if you can think of, for example, seagrass meadows are a very veritable fish factory and carbon store. And if you think, for example, other activities like snorkeling or diving, those alone generate billions in tourist dollars. Or oyster reef, another example, support very important fisheries, are filter pollutants and can reduce the impact of violent storms. And so when paired with salt marshes, mangroves, ocean currents, nutrient-rich upwelling and other habitats, the ocean really provide us with countless and invaluable services. So we need to cherish this wealth of services. The ocean has been estimated to produce around $1.5 trillion in global economic value every year. So our countries and economies all around the world really depend on healthy oceans. And from large-scale fisheries to all the way down to subsistence fishermen, the international luxury hotel chains, the 3 billion people that depend on the seafood as the primary source of protein. So in general, we all depend on the ocean and marine ecosystems, and we're collectively responsible for its well-being. We need to ensure that our marine ecosystem continue to provide these goods and services in a very sustainable way. And so in this sense, we should better understand how and where we depend on nature and harness scientific knowledge. We need to introduce innovative thinking in this and new technology that we now have available to ensure the continuity of these benefits. And so only this way we can truly improve and increase investments in marine conservation and improve management and restoration. Today I will talk to you specifically about the Mapping Ocean Wealth project, which, like I mentioned, has started around 4 or 5 years ago, and it was first developed at the global level and has now, in the past couple of years, been transitioned to a better, higher resolution, more regional level type of model. And so in general, Mapping Ocean Wealth, and I provide here a link for you to check out the main webpage, moves us from these broad global numbers to very specific local details. So it allows us to evaluate nature in marine and coastal settings as a true economic asset. So you could imagine then the data becomes very actionable and can inform engineering. It can also inform financial and policy language, and ultimately lead to better planning, conservation, and investment decisions by the stakeholders that are involved. Next slide, please. So how is the problem addressed today? Traditional data sources for especially tourism and recreational activities at the global level and also the regional level include government statistics and reports on tourism spending and visitation. This type of data is often tabular. You can think of Excel spreadsheets, or in some cases are written reports. We have also global databases that specify the location of hotels, diving sites, or shops. And also traditionally we have relied, especially for these global models, on just manual keyword searches from crowdsourced platform such as Flickr or TripAdvisor, and I will dive into one of them shortly. So limitations, as you can imagine, involve a very intensive process of data cleaning and data integration. So there is a lot of work that goes into it, and there is a lot of validation that's also required to integrate all these different tabular and written data sources, different databases, and this can introduce some data bias, so inconsistencies in general in reporting these details across different geographies across the planet. Also, it should be noted that patterns in tourism are very difficult to capture at the specific activity level. And so if you think of activities like diving, snorkeling, kayaking, and so forth, so what features are really drawing the tourist to a specific area, often this type of activity level nuances are very hard to find or capture, and you only find aggregate data for visitation available. And finally, there is a plethora of privately owned data sets that come with a number of data sharing restrictions, as you might know, or privacy issues for identifying specific locations. And that, of course, needs to be accounted for. And so in some cases, these data sets, even the proprietary ones, cannot be bought because of specific limitation at the local country level. And so, like I said, diving sites, for example, don't want to necessarily disclose the exact geographical location for it. Next slide, please. So first of all, if you are not too familiar with AI and machine learning in general, as Leila mentioned at the beginning, I recommend you check out the AI Primer webinar in the same series. The webinar is available on the NetHope Solutions webpage if you're interested. So if I mention concepts that are a bit too hard to grasp, feel free to check out the AI Primer, very helpful. And so in general, current studies of georeferenced photographic images have either ignored image content or gone to a very great effort to manually code and classify photographic content. So this can lead to, for example, include images that are irrelevant to the aim of the study or highly time consuming because of this manual classification, and suffer from some of the bias. Computer vision technologies and AI has exploded in recent years and can potentially solve issues of scalability and reproducibility of the analysis and some of the bias that otherwise would be involved with manual classification of photographic content. Computer vision includes computational techniques that allows us to gain high-level understanding of digital images or videos, and essentially seeks to automate the task of human recognition and classification of images. Computer vision is increasingly employed in several commercial and academic fields. For example, is used in automating repetitive visual tasks in fields like manufacturing, species identification, autonomous vehicles, deciphering ancient languages, and so forth. And moreover, more recently also employed in the medical field to enhance visual detection of disease from body scans. So it has a very broad range of application. And in this particular case, by using AI and machine learning technique, we seek to improve the accuracy and resolution of the data to map ocean uses that historically have been difficult to characterize. For example, tourism and recreation, like I mentioned, and increasing so the likelihood that stakeholder and decision makers will then have a better understanding of the value of the underlying value of the habitats that support these ocean uses. In this case, despite being a major driver economies in the Caribbean region, as a local example, data on partners of tourism can be very difficult to capture, and so AI provide a very, very good solution to complement existing aggregate methodologies. And we've used crowdsourced platforms such as Flickr to provide information on a specific type of activities like I said, diving, snorkeling, kayaking, and so forth. It provides also information, exact information where that activity is taking place. This is for geo-tagged images. And also, it can include perceptions around these activities. So as you can imagine, every photo, every geolocated photo often comes with text and reviews attached to it. So you can also extract some type of perception around these activities. Next slide, please. So what is our solution? Of course, ultimately we want to enhance maps of culturally and economically important tourism activities, and we want to better inform conservation planning and management of these ocean marine ecosystems. And we want to leverage AI and machine learning tools and computer vision technology so that we can have a better understanding in the variation of reef-dependent tourism. And by reef-dependent, I mean both on reef, such as diving or snorkeling, but also a reef-adjacent tourism that includes beach going or enjoying calm waters or seafood. So there is a number of activities that tourism activities that depend on the presence of coral reefs at the national or subnational level. Also, in the near future, we would like to extend this model that I'm presenting to you today to estimate footprint and intensity of things like recreational fishing and also other types of nature-dependent tourism. Next slide, please. So what kind of data does our solution need? As I mentioned, definitely georeferenced photos. So it has to have a spatially explicit location, a point with latitude and longitude coordinates that can be extracted for each of the activities of interest, the way we defined it. And we want to extract point densities, location, and also densities that could give us an indication of use intensity. And there is this concept of photo user day, or PUDs, that can be derived from using the date and the exact location attached to each photo. And if you are more interested in this concept of photo user day, there is a lot of literature out there, and I'll provide some links in the last slide of my presentation. So how we're getting this data? The data comes from Flickr as the main platform of choice. Flickr has a number of very, very useful applications that have been used in the past, and the photos are programmatically downloaded using the Flickr API, and specifically in our case with Python. And that's done to automate certain type of activities like metadata searching by a specific date range that we're interested in, or location range, and so forth. So that's all done using the Flickr API, and I also provide a link to for you to check out here. Next slide, please. So currently, from a technical standpoint, in terms of what resources are needed for development and implementation and maintenance of our solution, we're using Microsoft Azure and their cognitive services. Within cognitive services, which includes a bunch of other type of AI techniques, we selected the custom vision one. And custom vision allows you to essentially not only reuse one of the pre-made models, pre-trained models that Microsoft offers, but also retrain a model using your own set of images, and which was very important in our case, and also fine-tune these models based on performance. And it's all done. It can all be done in a very intuitive platform and a graphic user interface where you can basically see the results of your classification right in front of you, and not just numbers, but actually fine-tune what photos have been misclassified and so forth. So there is definitely a part of technical expertise needed there, and also there is a good amount of GIS expertise for any mapping task and basic spatial analysis involved with after these points, these locations have been extracted. Also, definitely maintaining a code repository such as platforms such as GitHub for reproducibility and documenting the methodology so it can be applied to other regions or other countries. From a non-technical standpoint, stakeholder engagement is very important to validate our results and also add complementary data context using for example, participatory exercises and review and in-person sessions and training. Definitely project management, a very important component when it involves all these pieces to the analysis and scientific expertise and local knowledge, which is the main reason why we, the Nature Conservancy also collaborated with a number of academic and nonprofit partners for this particular project. So it's a shared effort, definitely. Next slide, please. What potential biases can AI introduce or amplify? In this case, there could be a data source bias. For example, crowdsource platform cannot be expected to cover the entire range of tourism visiting an area, and in some cases could favor preference of users that are more likely to use those platforms. For example, people that are technologically savvy or people who have ready access to technological resources. One of the solutions potentially to this problem is that AI-derived results are only one of the input for our ecosystem service model. So we also rely on exit surveys, government data, and all the other sources of data that's available from the tourism industry. So this is really meant to be a complement to it. And as you can imagine, there is also a classification bias that involves false positives or false negatives type of classification. And here on the right, you see one clear example, for example, of a true positive for when we're trying to identify underwater photos for activities like diving or snorkeling, and a false positive where the model might think that the image is underwater, but instead it's just a blue sky, for example. So you need to be careful and fine-tune the models to your needs. Next slide, please. In terms of maintaining our solution, we have wide internal support. Thankfully, at TNC, we maintain GitHub repository for documentation and reproducibility of the analysis. We have a very good relationship with Microsoft and Microsoft Azure team. We have a sponsorship with them, and also outreach and partnership that starts from within TNC with local governments and stakeholders in the Eastern Caribbean region for this particular project that involves Flickr and computer vision. We also work with a lot of supporting partners and collaborators. So for example, the GEF and the World Bank that participate in project funding, the University of California, Santa Cruz for a lot of the AI and machine learning type of analysis, and Critigen for our web tool development for mapping ocean wealth. Of course, our sponsorship with Azure for our custom vision API, and ultimately NetHope for all the in-kind Azure grant donation that TNC has received. Next slide. So I'm going to do a very quick demo, and of course this is a publicly available website. So you can check it out yourself. I'm going to switch to sharing my own screen. Okay. I assume you should be able to see my screen now. And this is the what we call Mapping Ocean Wealth Explorer. And as you can see, it involves other type of projects as part of Mapping Ocean Wealth, some that have to do with natural coastal protection or coral reef fisheries app. What we're going to focus right now, just for sake of time, is recreation and tourism. And so what you can see is, first of all, you can start narrowing down your geographic extent of interest, whether it's global or a specific country or area in the Caribbean. It gives you some quick stats at the global level. And it also gives you some basic charts of on-reef tourism and adjacent reef tourism and the value and the dollar amount attached to it. So you can zoom in to whatever region of interest you prefer, and the model, sorry about that. The model provides you with this color-coded legend that's tied to a dollar amount of the value, the model value for reef tourism in this particular case per square kilometer. So it gives you a very spatial, explicit way of assessing which areas have the most value, and as a consequence, have a better idea on where to allocate economic resources for planning and management at the local level. So in general, I just recommend that you play around a little bit with this application and look at the different type of information that can be extracted, and you can do the same for the other type of models and activities that I mentioned. I'm going to switch back and go back to the slides, if you don't mind sharing them again, Madeline. Okay, next slide. So to summarize some of the results from this first bulk of work and accounting for piloting work that we're still doing, so some of these estimates will be enhanced. We accounted for about 70 million trips, and we estimated about 19.5 billion of in dollars in terms of on-reef tourism value, and reef adjacent tourism around $16.3 billion. More than 70 countries have $1 million reef industry and rely on it. And this Mapping Ocean Wealth project, we're very thankful for receiving this Tourism for Tomorrow award in 2017 for the innovation and the methodology that has been employed in it. So if you're interested, definitely check out the website to get a little more insight and information about it. And then finally, in the next slide, the final slide, I'm providing some very useful references that some are published literature for if you're interested in what type of model, the point locations from the computer vision analysis, what type of model has been used in very detailed. So these two publications, 2017, 2019, I'll recommend you check out. Also, these two videos that I'll be providing, and you will all receive as a link after the webinar, Transforming Our World, and especially the last one, Mapping Ocean Wealth with the Power of AI. It's a very nice video that essentially gives you an idea of some of the concepts I've talked about today. And feel free, please, to share these resources with your network, especially if you know those that are working on similar conservation issues, ecosystem services, or sustainability. And yeah, feel free to check out the resources that I'm providing here, and also follow up on ongoing project updates for these AI-related methodologies that we applied. Thank you very much.
Great. Thanks so much, Francesca, for a fantastic presentation and also incorporating so many beautiful images. Just a one note, we've noticed a bit of a delay between the slide transitions. We're still getting used to Zoom for these webinars, so apologies for some of the delays, and thank you for your patience with that. Well, with that, we'll transition into the Q&A. We have about 10 minutes, so do continue posting your questions in the chat window. So the first question is regarding the oceans data. So oceans data, as you said, Francesca, is notoriously sparse and disjointed. Is there a uniform level of granularity in the data? Is it all per kilometer square, or are some areas valued at a different scale? If you can talk about that a bit.
Yeah, so when you extract information from the computer vision model, you extract location of the exact latitude and longitude of the photo. And as I mentioned, a lot of times there is heavy users of Flickr that might post a bunch of photos even on the same day on a nearby, say, set of locations. And so when you go down from that point granularity to the actual model, and specifically the photo user day, the PUD concept, then the resolution is really a fine-tune exercise where you decide how to best extract pixels, essentially, that truly represent the activity and the intensity of multiple users, not just one heavy user. And so for the global model, we compromised on model performance and also granularity using a square kilometer. But for the Caribbean, Eastern Caribbean pilot that we're running right now, we're trying to go to see if we can go down below a kilometer, have a higher resolution, but it all depends in some cases how many photos are actually available for that particular grid cell or pixel, and also how much is the model performing differently in terms of classifying after you select that specific resolution. And so what you want to do is really pick a few different, I would recommend a few different resolutions, and then test how that changes your final outcome. There is no like hard set decision here. And also in terms of integrating different resources of data, you shouldn't just rely on these AI results. You should try to integrate whenever possible with local reports on tourism, if those could be available to you, visitation, exit surveys. And so all of those can give you additional elements for estimating your intensity and your use for that geographical area.
Thanks, Francesca. There's a follow-up question from Francesca, who asked the first question. Also, you mentioned that a robust ecosystem services model would include further inputs to balance out some of the data biases. So what other inputs would you recommend?
Yeah, and so that kind of goes back to what I just said. Basically, if available, you should try to include work with local stakeholders if they can provide exit surveys or local tourism data that accounts for like number of tourism that are visiting or staying at hotels or that come to specific shops or restaurants even. So you want to see if you can include for this kind of different activities. In some cases, it could be hard because, like I said, often it comes at the aggregated level. And if you want to differentiate between, restaurants or beach going or enjoying calm waters, diving, snorkeling. So there is literally like a lot of, I guess, gray areas where you need to work with local stakeholders on that.
Great, thanks for reiterating that point. A general question for both of you, given that AI is still pretty nascent in our sector, whether it's humanitarian development or conservation space, for those who are thinking about using AI for their work, so for the field programs or even internally, what are some of the things that you found that they should consider before or when getting started? Let's either Faye or Francesca, if you can just share any additional thoughts on that.
Faye, you want to go first?
Yeah, so I think the first question is whether AI is suitable. So I think the framework that NetHope is developing is great. It helps to guide people to think about whether it is helpful and why it is helpful and how it can be helpful. I think that's the first question to answer. And second is build upon others or existing solutions. It's not necessary to start from scratch. There's a lot of tools available right now about machine learning, and there's also all kinds of resources or tutorials online. And even if and the third one is if you realize that this is a very new problem and the existing tools doesn't help much, then you can potentially reach out to the researchers in the field and get help from others, or even just post the problem to, let's say, NetHope and kind of call for solutions or call for collaborations, I think that would also help in building a solution in a more efficient way.
Great, thanks, Faye. Francesca, your thoughts on this?
Yeah, definitely agree with Faye on all she said, and I think NetHope provides a very nice space for people that come from very different types of NGOs in their field they're working on to share this kind of cross knowledge. And in some case, it could be that a specific model has been applied, but it just in a slight different field. In conservation, AI and machine learning is fairly new, and conservation, I think, is still catching up in a lot of those things. But there are other fields that have been applying it. You know, if you think of computer vision, like I said at the beginning, a lot of other fields have used it for a long time. And so it's just a matter of figuring out what type of questions and problem you're trying to solve. And I think there is a lot of expertise that can be shared across partners.
Great, thank you. And just a note on that, so in addition to learning from these practical implementations, we'll have at the summit the opportunity to pair you up with some of the AI subject matter experts, so you can bring your expertise in specific kind of problem area and explore if, as Faye said, AI is even the right solution for what you're trying to do. With that, I think Faye and Francesca, through your very informative presentations, I think you've answered all of the questions, it looks like it. So we'll give you all a minute to also complete the poll. And I would just make one note before handing it off to Madeline. It would be helpful for us to also hear from you what additional topics you'd like to see covered. You've seen the overview of the topics that we have already covered or have planned for the next 2 months, and that's based on the input from our AI working group that actually Francesca is a member of. So if there are any other topics that would be helpful to you, or if there are things that you would like to, like practical implementations, that you would like to share with this community, let us know. And a huge thanks to Faye and Francesca for sharing their work, and also for having some really specific calls to action for all of you and how to get involved in the work that they're doing. Madeline, over to you for the closing.
Thanks, Leila, and thanks to all the attendees today for attending the session. If you would please take a few minutes just to complete our satisfaction poll, we very much appreciate your input, and have a great rest of your day.
Leila and Madeline for hosting this.
Thank you, Faye. Thanks, Francesco.
Thank you, guys. Talk soon.